Hello guys, welcome back to my channel Rydon Academia. Today I'm going to be rounding up the series that we started. In our previous classes we were able to look at like and unlike terms. We introduced algebraic expressions, like and unlike terms. We saw how or when to add and how to add like terms, because like I said, we cannot add unlike terms, right? I told us when to add and how to add like terms, and then I also told us how to multiply. That was the last video we did. And then today we're going to be looking at the division of algebraic expressions as it's written on the board. Now, when we come to the matter of division, I would like to explain that concerning division, we have to look at both like terms, and then our emphasis is on the common terms, between what we are dividing and then the divider. That's the number that is dividing, what we are dividing, that's the whole number, that's the numerator, in fractional terms. We'll talk about the numerator and then the denominator, or what we are dividing and then what we are using to divide. Let me use that word, let me use those terms. I'm going to be starting this class with simple examples, So we'll be taking it step by step. We take today's class on division step by step, Now, for the purpose of emphasis, I'd like us to know that we cannot divide unlike terms. When we have unlike terms, maybe the numerator is a different term, the denominator is a different term, we cannot divide them. Let's establish that. That means I'm saying that if you have x squared and we are dividing by y, this is x and this is y. Now in the case of division, like I said for multiplication, in the case of division and multiplication, when we talk about unlike terms, we're just looking at the when we talk about like terms, we're just looking at the variable itself, not considering the power like we do in addition and subtraction. When we are adding or subtracting, we have to consider the like terms in terms of the variable one and then the power of the variable. That's for addition and subtraction. But the case of multiplication and division, we consider like terms just in terms of the variable alone, same variable, So that's the emphasis. We need to know that. Now, this is it. So we have x squared and then we have y. Now the variables here are unlike because they are different variables, not minding the power, So the variables are different. It means we cannot divide it. So our answer will still be the same, x squared divided by y, That will still be our answer. So for emphasis purpose, like I said, we cannot divide unlike terms. We only divide like terms. And then what we do when we are dividing is that we try to see if we can get the highest common factor. There's something called highest common factor. That is the greatest number that is common in both the numerator and the denominator. That's the greatest number, the greatest factor, the greatest variable, the greatest expression that we can find in both the numerator and then the denominator. Then we use it to cancel out each other in both cases. Now, from like I said, we'll be going step by step, right? So let's start from the simplest division. That's the simplest form of division, where we just have like terms dividing like terms, just like variables dividing themselves. Very easy. So when we are dividing like variable, let's say x raised to power 5, and we are dividing this by x raised to power 2. Like variables or like terms, like I said, in the case of division and multiplication, like term is just focus on just the variables, that's just the letters, or just the numbers. If we're dealing with numbers, just the variable itself, that's the base, the base, the whole number itself, not minding the power. Now, so in this case, we have to, when we are dividing like terms, simple, what we do is that, like I told us, the law of indices that state that when you are multiplying, that was in our last video, right? And when you are multiplying indices of the same base, you add their power. When you have indices of the same base, that's the same variable multiplying themselves, you just add their powers together. Now, the opposite is the case for division. There's also a law, the division law of indices, that whenever we are dividing indices of the same base, where you have the same base, that same variables, subtract the power. When we are trying to divide, in this case, we subtract the power of the divider. The divider, in this case, I'm talking about the number that we are using to divide the whole number. We subtract the power of the divider from the power of the divided. That is the one that we are dividing. So the one that we are dividing, or let me use the word numerator, denominator. So we subtract the power of the denominator from the power of the numerator. That is where the same variables, okay, the same base, the same variables, or the same numbers whenever we are dividing. Okay, so this is it. Now let's assume this is x raised to power 5 and we are dividing this by x raised to power 2. Now because the bases are the same, okay, we can subtract the power. We are subtracting the power of the divided, okay, that is 5. Then we are using we are subtracting the power of the divider from the divided, okay, so that we have 5 minus 2. So we are subtracting the power of the divider. This second person is dividing the first person. So we are subtracting this power from the first person's power to give us what? X raised to power 3. Reverse is the case. Even if you have a bigger power coming second, that is if your divider is carrying the bigger power, you still apply the same thing. So if we have y squared and we are dividing by y raised to power 4, okay, if you want to divide this, the same rule apply, please. You are always subtracting the power of the divider from the power of the divided because the bases are same. The first thing you have to establish is that the bases are same. Okay, please don't forget that the basis has to be same. Now we have y, same basis, then we can apply the law of indices, okay, division law of indices. Now this is our divided. Even though it is greater, we'll still subtract this power from, this is our divider. Now even though it is greater, we're going to subtract this power from our divided, okay? So we're going to be having y raised to power 2, which is this, minus 4. That's the power of the divider, okay? And that will be giving us what? Y raised to power minus 2. 2 minus 4, positive 2. You have 2 and then you are subtracting, you are owing somebody 4, okay? What you have at the end of the day is minus 2. If you don't want to write it like this, you can now bring it inverse law, okay, which is another, I think we have done this, the law of indices, inverse law. So we bring in 1 over y raised to power 2. Okay, so this is it. This is it. This is the simple. It is the simplest. Let me say this is the simplest division problem we are going to be having. Now let's go on to the next step. Okay, like I said, whenever we are dividing, we check for what is common, the numerator and the denominator, or what I use the word the divided and the divider. Okay, yes. So we try to see what is common in both cases and then we can strike out. All right. Now let's try something else. Let's try to see how we can factorize, because in division also we try to see how we can see what is common, like I said. So we also try to factorize. Now let's go. We have this. So we have 10x squared, or should I say 10, okay, 10x squared. We are dividing by 5x, okay? We want to divide this a step further, right? Now, I want to add signs so that we know that division also involves signs, please. Yes. So in division, same way we did multiplication, division also involves signs. So signs will divide signs, the numbers will divide numbers, then the variables will divide the variables, okay? That's another simple method, right? So now the sign here, as you can see, is minus. There's no sign here, that means it's plus. So the rule for minus times plus applies for minus divide by plus. That is, minus divide by plus is minus. Minus divide by minus is plus. Plus divide by plus is plus. And then lastly, plus divide by minus is minus. When you have two different signs dividing or multiplying, the answer is negative. Minus times plus is minus, and minus divided by plus is still minus. When you have two different signs and you are multiplying or dividing, your answer is always negative, okay? Now, this is it. So we have minus divided by plus, because like I said, when there is no sign, that means it is positive. So minus divided by plus give us minus, so we have minus for this. Now, 10 divided by 5, number will divide number, okay? 10 divided by 5, what is common up and down is 5, okay? 5 can cancel this and this, so we are left with 2, yes? And then the power, okay, like I said, when we are doing logarithm of the same base, subtract the power. X squared divided by x squared divided by x. Okay, the power here, like I said, whenever you don't see a power, it's 1 raised to power 1. So we are going to subtract the power. We have 2 minus 1 to give you 1, okay? And x raised to power 1 is the same thing as what? X. Now let's see how we can make use of something a bit demanding, okay? Let's see how we can divide when we have something that is a bit demanding, okay? Now let's say we have something like this. Let's use a perfect square, x squared minus 9, and we are dividing by x plus 3. Okay, we want to divide x squared minus 9 by x plus 3. So how do you divide? Like I said, we try to see if we have anything common, okay, anything in common. Now, if you look at our numerator is a perfect square. Yes, I think there's another method you can do. Okay, we can use conjugate of the denominator, right? To multiply both numerator and denominator by the conjugate. That's another way you can go about it. But I want to use another method which has to do with factorization. Now, this is x squared minus 9. I want us to look at this that x square, this is a perfect square, okay? And then 9 is also a perfect square because we know that the square root of 9, we know the square root of 9, and then we know the square root of x square, okay? So we can now use perfect square method. There's something called the perfect square when we are solving maths, that whenever you have two perfect squares simplify like this, okay, you try to take the square root of the first one, which is x. The square root of x squared is x, okay? And then this sign, what we do is this. So we take the square root of the second person, that's 9. The square root of 9 is 3, okay? So the sign minus, like I told us, minus times plus is what? Minus, okay? This sign is minus, is a product. So we have to know that one of these signs will be carrying minus and the other one will be carrying plus. It's as simple as that, okay? So this is a perfect square, this is a perfect square, and there's a minus in between. That method works as long as this is the setting. As long as you have two perfect squares, a minus in between. This is a simple trick to do. Take the square root of the first, take the square root of the second, that's 3, okay? Now share these signs for them, okay? So the first person will be carrying minus 3, and then the second person will be carrying x plus 3. So this is it. This is such that whenever you open this bracket, you expand this bracket, or you simplify the bracket, you will arrive at x squared minus 9. Okay, you arrive at x squared minus 9. So don't forget this. Very, very important you know this. Okay, so you have x squared or y squared or z squared, as long as it's a perfect square, and then you have minus 9, okay, or any other perfect square, 16, 25, or 4, like that. So you have perfect square attached, okay, and then there's a minus in between. This is what you do: square root of the first one, square root of the second one. Now split this sign. Minus times plus is minus, so you have the splitting. Minus goes in one bracket, plus goes in the other bracket, okay? And then we are dividing by our denominator, which is constant, x plus 3. This is not a perfect square, okay? This is just x, this is just 3. Now we have something in common. Yes, this is x plus 3, this is x plus 3. So what is common can strike out each other, and then we are left with x minus 3. Are we together? So I hope that you've learned a lot from this video. Like I said, it's more of looking at the basic things, okay, basic things that people misunderstand, okay, in maths, when solving algebraic expression. These basic things that people misunderstand, and then it can always make them to make unnecessary mistakes, okay? You always lead them to make unnecessary mistakes. So with this, we've come to the end of this series on algebraic expression. Do well to like this video if it was helpful to you. Subscribe to this channel if you haven't, and click on the notification buttons here so that whenever new videos drop, you will be notified immediately, okay? You can share this video, like I said, with as many as you can, and then we'll see you in our next classes. Thank you.